Morning, Year 6. Tuesday, let's do some maths. Volume. So we've gone through area and we've done some work on perimeter, and we're now going to have a look at volume, specifically by counting cubes. So prepare your page and let's get going. So have a look at this. How many cubes are needed to create these 3D shapes? What I've done for you today is combine a refresher lesson and an extension lesson. So it's going to be a slightly longer session with me than you're used to. Just pick up a pen. When it says count the cubes, it literally means count the cubes. 1, 2, 3, 4, 5. Okay. Pause the video, have a go, and then we'll look at the answers. Five cubes, 3 cubes, 4 cubes, 5 cubes, 1 cubes. So far so good. Seems quite straightforward. What are we counting the cubes for? What are the cubes telling us? If we're not looking at perimeter, we're not looking at anything around measuring the lengths, we know that area was the space within a shape. What kind of shapes did we tend to look at? Were they 2-dimensional, 3-dimensional? Because here we got 3-dimensional, remembering that 3-dimensional shapes have an X and a Y axis, but they also go back as well. So you got that sense of solidness, if you like. Therefore, what's the volume of each of the shapes? Now, this question is, what is the volume of the 3D shapes? And all we have really are the cubes. We're 1, 2, 3, 4, 5, 6. When we get here, what if each one of these cubes was 1 centimeters cubed? Now that's interesting, isn't it? So perimeter would be just the units of length, centimeters. Area was squared, and now we're on to cubed. So what's the volume of each shape? Have a think about it, pause the video, and then we'll look at the answers together. The 6 cubes. So if you were a little bit stuck, 1, 2, 3, 4, 5, 6, I reckon you could probably pause the video looking at that one and do the other 2. If you were absolutely fine with that one, let's move on. 6. What's the last one going to be? 6. So what can we say about each of these 3 shapes? Equal, same, equivalent. What about this? 1, 2, 3, 4, 5. Does that mean it's 5 cubes? Let's check. 5 centimeters cubed. 5, and it's 5 of these. 5 of these 1 centimeter cubes. So if you didn't manage that one, pause the video, have a go at this one. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9 centimeters cubed. 1 cube. 3 cubes. Volume is the amount of space an object or liquid takes up. So volume is the amount of space an object or liquid takes up. Have a think about that. What's the volume of each of the 3D shapes? No. So we've got 1, 2, 3, 4, 5, 6, 7, 8. How else could you write that? On the reasonable assumption that each of those are 1 centimeter cubes. How else could you write that? Or could we call it 4 centimeter cubed? What about the green one? 6 cubes, could we call that 6 centimeters cubed? Ah, okay. Let's go back. Okay, so these are essentially, they're just stacked upon each other, aren't they? Yeah, it is a bit different because 1, 2, 3, 4, 5, 6, 7, 8, but somewhere in there, there's going to be another one, surely, isn't there? Have a think, pause the video. Do you agree with the tortoise? Or are you thinking maybe I'm onto something? If you have any cubes like this, maybe you could build it. Let's have a look. One, 2, 3, 4, 5. Okay, 6, 7. What happens next? 8. Oh, we can still just about see it there, but not now. So we need to use a sense of our perception and the way we can view three-dimensional shapes in space. And for some people, it's quite straightforward. It's quite natural. In others, you have to learn it. I can't remember which I was, but I certainly know that three-dimensional work, if you ever do organic chemistry, is there a lot. But it's certainly a skill that can be learnt. 9 cubes. What's that? Okay. Like a cube. Okay. What's happened there? 1 cube. How many cubes? 1, 2, 3. Seems like each stack is 3. 1, 2, 3, 4. 4 stacks of 3, maybe? Okay, so let's build it up. 12 cubes. So I said stacks of 3 and that there were 4 of them. What is 4 times 3 or 3 times 4? 12. There we go. So if the cubes themselves are 1 centimetre, they have, so what you're looking at is that that would be 1 centimetre, but so would that be 1 centimetre, so would that be 1 centimetre, so would that be 1 centimetre, so that one. So the whole dimensions are all 1 centimetre, and it becomes a 1 centimetre cube. Have a think about this. What's the same, what's different about these 3D shapes? Okay, so the volume of each 3D shape is 4 cubes. Hopefully by now that's okay, because you're counting them. 4, 1, 2, 3, 4, 1, 2, 3, 4. Great. But they've been arranged differently. So their position in space is different. This is almost like a wall of 4, a tower of 4. I'm not sure about this. An L of 4. Seven cubes. Thirteen cubes. Are we sure on this one? They were lighting up along the bottom. But if you look, 1, 2, 3, 4, 5, 6, 7, 8. What do you think? "16 cubes, yeah, I'm in agreement. So we had 8 and 8 on the bottom. That's 16. Oh, 16 cubes. Could we call that 16 centimeters cubed? What about this one? What's the volume of this shape? You may look at this differently to somebody else that you're working with, but if you imagine, we can see that one cube stacked upon another. So we've got 1, 2, 3, 4, 5, 6. We know there are another 6 below that, so that would be 12, 13, 14, 15, 16, 17, 18. So what do we think is 18? How else could you do that? 1, 2, 3, 3 fours for 12. That would give you the 12 plus the 6. Yeah. 12 and 12 is 24. Minus 1, 2, 3, 4, 5, 6. That would work as well. Checkpoint. We have 2 checkpoints today, and when you get to the activity, you're looking at doing all the questions. Have a read. Pouring water out of a jug reduces its capacity. True or false? Explain why. So let's read through this. False. The volume of water in the jug will be reduced, but the capacity of the jug, the amount a container can hold, does not change. Does that make sense? So the capacity is the capacity that the jug has, the ability to hold a certain amount of liquid. And the capacity would be marked by this maximum amount of water. So have a go at questions 1 to 4 on the worksheet. Pause the video and take the time that you need, and then come back to the video, whether you've paused it, unpause it, or turn it back on, and continue. Take the time you need. See you in a while. Hi there, welcome back. Hope you got on okay with those. Do self-assess using the marking station to check your progress. Let's do a little bit more exploring. If 1 cube is worth 1 centimeter cubed, what's the volume of this shape? How many have we got on the top? 3 times 3. So each layer is 9. How many in total? 2 9s. 18 centimeter cubed. So we were writing using the known units of volume. It's whatever the length is. In this case, we've got 1 centimeter dimensions, and then it's cubed. So a cube. Again, if 1 cube is worth 1 centimeter cube, which shape has the greater volume? So pause the video, have a think. Okay, let's see how you did. Now from inspection, 1, 2, 3 layers of 8. Now this also has 3 layers, but it has a gap here. So what would instinct tell you? If we're thinking about volume as the amount of space this 3-dimensional shape is taking up, you drawn to this one. Let's do another checkpoint, just to check your understanding, see where you're up to, get ready to move on. The models have the same volume. True or false? And explain why. Let's have a think about that. Pause the video. So both of the models are made of 8 cubes. So we have this one. Let's start with this one because this one's easy to see. 1, 2, 3, 4, 5, 6, 7, 8. So that one is definitely 8. And what about this one? How are you going to do? Well, 1, 2, 3. Well, you can see it's one upon the other, so it's a height of 2. So if you've got 1, 2, 3, there must be another 3 under there. So that's 6. and then we got that one and that one, so that's your 8. If you're not quite sure, pause, have a look at it. If you do happen to have any cubes, maybe bits of Lego. I think Lego has little square shapes. They don't need to be 1 centimetre. You can kind of get a feel for how some of them get hidden in this 3-dimensional drawing. And then have a go at the rest of the questions on the worksheet. There we go. So that video was about 20 minutes. That wasn't too long, actually, if you've gone all the way through it. But if you want to pause and take your time, it might take you maybe half an hour or a little bit more. So spend about an hour in total on the maths and do your best, as I know you always do. Okay, Year 6, take care.